Okay, we're going to take a look at your functions quiz that I gave you last Thursday. Many of you did pretty well on this, and if you felt that you struggled, this is a good idea to watch this because you're going to see it again in future quizzes and future tests. Just because we've done it once doesn't mean it's not going to show up again. So let's go ahead and take a look at this. Number one here. This is a composite function. All right. So basically, what we're going to do is take this input 5, and we're going to plug it in as an input for g. So this x right here, now it's going to become a 5. So what we're basically saying is we want g of 5. Right. So this x is now 5, and now we're going to have this is going to be 2 times 5 minus 10. 2 times 5 is 10, so 10 minus 10 is of course equal to 0. Alright, now this is the output for g of 5 right here, and now we're going to plug 0 into f for x. So what we have here is f of 0 instead of f of x. So f of 0, we're going to make this a 0, 0 squared, minus 2 times 0, minus 15. Okay, remember this goes to 0, this goes to 0, so this answer is simply going to be negative 15. That's what's going to happen. That's all you do. You plug this into g, get an answer, and then take that answer and plug it into f and get a new answer. That's all there is to it. That's what this composite function means. Alright, let's scroll down to number 2. What this basically equates to is f of x plus g of x. So we're just going to add these two functions together. So here's f of x, so let's just write it out, I guess. We'll do that. X squared minus 2x, crazy here, minus 15. And we're going to add g of x, which is up here. G of x is 2x minus 10. Alright, so like terms, we can only add x squares to other x squares, and we don't have any other x squares besides this one. So we're just going to write x squared. That's used up. We have x's, or like terms, we can add those together. Negative 2x plus 2x. Well, negative 2x plus 2x is nothing. It's 0. So we can just say these cancel out. Now we have negative 15 plus negative 10. Same thing as negative 15 minus 10, which is going to be negative 25. And that was the answer for this one. Okay, some of you actually went a step further and factored this. Wasn't necessary, but if you did, that's okay. This is a difference of squares, so you could say this is x plus 5 times x minus 5, and that would have been okay as well. It's the same thing, same answer. Okay. All right. Number 3 here. We're going to divide them this time instead of adding them. So this means basically is f of x divided by g of x. All right. So we have this again. We have x squared minus 2x minus 15 divided by this time 2x minus 10. Now, if you wrote this, you didn't get credit for it because you need to simplify this quite a bit. We need to factor the top here and the bottom, so we need to factor the top factors of negative 15 that will add together to give you negative 2. All right, those factors are negative 5 and positive 3. Negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. And on the bottom, we can actually factor out this 2 right here. So we can write that as 2 times x minus 5, because 2 times x is 2x, and 2 times negative 5 is negative 10. And what you see here is that this factor and this factor are identical, so they cross out. So now your answer is actually x plus 3 all over 2. If you went a step further, you probably could have written this as, or did write this as 1/2 x plus 3/2. 1/2 x plus 3/2 is also an acceptable answer. Alright, let's keep moving. We have another composite function, so remember this could be written as p of g of x. So we need to find g of x first. We're going to plug x into the function g. Alright, as it turns out, we don't have to do that because g of x is already here. We already know what g of x is. This part right here is actually equal to 2x minus 10. So what I really have here is p times 2x minus p of 2x minus 10, not times. P of 2x minus 10. So 2x minus 10 is going to be the input for the function p. Here's the function p right here. We're going to turn this x into a 2x minus 10, which means we have to turn this x as well into a 2x minus 10. So what this is going to equal is 1/2 Not times x now, it's times 2x minus 10. And then plus 5. So 1/2 times 2x is x, and 1/2 times negative 10 is negative 5. And don't forget to add the 5 over here. This will make 0. So your answer here really is x. That's all that's left. Okay, so that is your answer for this one. It's just x. And what you should notice about this problem is that that's what you started with. Your original input is the same thing as what you get out. What this suggests is that the functions p and g are inverse functions. Because when you did a composite right here of these two functions, the input is the same as the output. It doesn't have to be x. If you put a 2 in here, you should get a 2 out of here if these are in fact inverses. Now we have another composite function with h calling on itself again. So right here we have -1 that's going to get plugged into the input for h. So here's h. We're going to make this x a -1. So I'm going to start with h of -1, and that's going to equal -1 squared times 2 minus -1. Okay, so what that tells me is that 2 minus -1 is actually the same thing as 2 plus 1, which is 3. -1 squared is just 1. So we got 1 times 3 cents, so that's equal to 3. 3 is now going to get plugged into here. Alright, so this becomes 3, like I said, this thing right here, and this is now going to go back into h. So now we have h of 3. So back up here at the top here, this x is now a 3, and we'll figure this out. So this is 3 squared times 2 minus 3. 3 squared is 9, and 2 minus 3 is -1. Oops, I don't know why it's doing that. And 9 times -1 is -9. That's your solution for number 5. Let's go on to number 6. And this, what you should notice, is actually very similar to number 4. Instead of P and G, this composite order, we've actually reversed them. So now we're going to plug X into P first, and then we're going to take that output and plug it into G. If you recall, the equation P is 1/2 X plus 5. So we're going to take that now and plug it into G. So it's G of 1/2 X plus 5. Alright, and remember that G, of course, this G function right here is 2x minus 10. So what this equals is 2 times 1/2 X plus 5 and then minus 10. So we turn the X right here into 1/2 X plus 5. So let's see what happens. 2 times 1/2 X is X, and 2 times 5 is 10. And now we'll subtract 10. And these will cancel out, and this is equal to X now. Same thing again. This input that we started with is now the output. Okay, same thing that happened up here in number 4. Even though we switch these around, it doesn't matter because these two functions are inverses. You'll get the same output. The output will be identical to the input. So these are inverses again, inverse functions. This always happens even if you flip it around. So that's the follow-up question. Based on your answers and our class discussion, which of these solutions is special and why? We will say the solutions for number 4 and 6. The composite functions show that P of X and G of X are inverse functions. Inverse functions. Or anything similar to that. That's what you should have seen. Let's go on to the following question now, the following page. These are questions for domain and range. Okay. So the first one we start off with is a sinusoid, and this is going to continue indefinitely forever. This direction and this direction, the same pattern. So the domain is very easy in interval notation. We'll say it's from -infinity to infinity. Remember, you can't include infinity, so we always have a rounded parenthesis around these, either negative or positive infinity. The range is a little easier, or a little more intuitive, I should say. The range is the set of y values defined by the function, and here we have the lowest y value being -6, and the highest possible y value being 2. Alright, so we say from -6 to 2. Remember, it has to go from lowest to highest. The order matters. Many students did not correctly order these domain and range, and they lost points for it. Okay, so -6 to 2. This is inclusive because these points are actually on the graph, so we're going to put square braces around this, square brackets. Alright, so let's go on to number 2. Okay, we're looking at number 2 for you. Let's go ahead and do the domain and range for this. I'm going to write domain here. Alright. And the domain is basically the set of permissible x values again, so we're going to read this from left to right, just like we would a book. Okay. So if I imagine this graph going this way, this direction forever, okay, it's going to go to the left forever to negative infinity is what I'm thinking, right? So I'm going to start there with negative infinity because that graph is going to go to the left forever. As I move to the right, though, across this axis here, if I go to the right and keep moving, I have to stop here at -4 because that's where the graph stops. So I'm going to put at -4. We can't go any further, at least for the time being. And that's a closed circle, so that means -4 is part of the domain. So we have to include it by showing a square brace. That's what I'm telling you. When I put the square brace, it means include -4 into the set of domain values. Now there's a big hole in the graph here until it picks up again right here. The graph starts appearing again. This x value right here is 0. Remember 0, 1, 2, 3? Well, this x value right here is 0, and this graph is, although it's increasing, it's going up, 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 up forever closer to 0. It's never going to reach it. So I'm going to pick up the graph again at 0, but it's never going to actually become 0, so I'm going to put a rounded parenthesis, meaning don't include 0 because it's actually not part of the domain, because we're keeping in mind there's a vertical asymptote right here, right on the y-axis here. So I'm going to keep moving to the right from 0, and I get to 2. And do I stop? Not really. There's a hole right here, but it's actually filled in right here at 2, even though there's a hole. So I just keep going after that, and this will keep going on forever. There's actually no real break in the domain from 0 onward to infinity. Alright, so I'm saying from 0 to infinity, there's no break in the graph because I get to here, and it's at 2, but remember, even though it's not defined up here, it is defined here, so it still counts, and there's no break afterwards. So we're going to union these two intervals together in interval notation, and that's the domain. We take this piece and then we add it to the rest. Okay, let's do the range. Alright, and let me see if I can erase some of this stuff. I got a lot of stuff showing up here. See if I can erase some of the stuff I've added on here. Get this picture a little cleared up. Alright. Okay, so let's go back and let's get this pen going. Alright, so, I don't know. I say red, never really shows up. I'm going to go from bottom to top for the range. That's how I read it. So if this graph continues downward forever, it's going to reach negative infinity. Right? And then I move up the graph. I'm going to move up the graph, up this y-axis in other words, till I get to what? Till I get to -3. I can't go any further after that. So it's going to go from negative infinity to -3. That's a negative, by the way. Let me erase that. It doesn't look very good. Let's get that back. I'm going to go from negative infinity to -3. That's a lot better. And because this point is included at -3, I'm going to put a square brace to show that. And this is a rounded brace on the left side here. Okay, so I'm moving up the graph. There is no graph here. No graph, no graph, no graph, and then I see a graph right here. And this is going to pick up, and I told you in class, I believe, that's right about 0.5 or 1/2, that y value. So I'm going to say 1/2, and it's a closed circle, so it's inclusive. And this is going to move up this graph here all the way up to what? To infinity. Now you're thinking, what about this part? But it doesn't really matter what this part of the graph does, because all of these y values that it has are also included in this graph already. So all of these y values are included in this range right here. So I actually don't really care about this graph. I'll only look at this part right here, because all the range values on this graph will incorporate all the range values in this graph already. So this goes from 1/2 all the way up to infinity. And we don't include it, and we're going to union that. And that's going to be your range, and that's the answer for number 2. All right, let's go down to number 3. All right, we're going to finish off here with number 3. Let's start with the domain for this graph. All right, so number 3, I'm going to start from left to right. All right, so this graph is going to continue this direction here, this direction forever. All right, so it's going to go all the way to negative infinity if it's going to the left. So I hit all these x values all the way this way, this way, this way, this way, this way, until I have to stop here at -2. And I have to stop here because that's where the graph stops, right here. And that's an open circle. So it goes all the way from negative infinity all the way to what? To -2. So from negative infinity to -2. Oops, I should say -2. I don't know why it does that. Let me erase that. I don't really like the way that looks. It's going to bug me. Alright. There we go. And -2. Okay. And we don't include that because there's an open circle there at -2. So -2 is actually not part of the domain for the actual graph. So we're going to put a rounded parenthesis to show that. Okay? We keep moving to the right, from left to right. So we keep moving to the right, and there's a break right here. From -2 to what? To -1. There's a break in between here and here in the graph. There is no graph right here. But it's going to pick up again at -1. So that's where going to be my next point. And that's a closed circle. So -1 is part of the domain. So we're going to put a includes, which is a square brace. And we keep going to the right. As I move to the right, this thing gets closer and closer to what? Gets closer and closer to the y-axis. And what is the x value on the y-axis? It's 0. You know, like 0, 1, 2, 3, 4. I'm getting closer and closer going this direction to the right, mind you, to what? To 0. But I'm not going to reach 0 because there's a vertical asymptote right there. So I'm going to keep moving closer and closer down this graph right here until I get closer to 0 but never reaching it. So I'm going to put 0, but I can't include it because it's actually never going to reach it. And then I keep moving. Alright, so it's not going to be 0, but it's going to pick up again also here on this x value, which is also 0. So it's going to pick up at 0 and keep moving to the what? To the right from here. It keeps moving to the right, moving to the right, moving to the right as I go down the graph. We're just going from 0 this direction. And I hit all of these values. Okay? So I have to stop here at 2 because I can't go any further to the right. I have to stop at 2. Keep in mind, when I say 0, we're not including 0. So it's going to really go like this. I'm going from -1 to 0, but not including 0, and then picking up from 0 to 2. So really what I'm saying is I'm going from -1 to 2, but don't include what? 0. That's what I'm saying. Because this particular vertical asymptote is not part of the graph. You can't go through the y-axis. The graph doesn't do that. So I'm going to put a rounded parenthesis at 2, because that's do not include. It's an open circle. And then there's a gap on the graph here. From here to here, there is no graph. Okay? There's no graph. There's a graph here. And there's a graph here, but in between here and here, right here, you can see there's no graph. So we're going to pick up the graph again at 4. And we're going to go to the right. So this from 4 is going to go on in this direction to what? To infinity. From 4 to infinity, because it's going to go forever. And that's a closed circle, so I'm going to put a square brace and a round brace here. And then we're going to put all my unions in. Union, union, union. We're going to union all these intervals together to create our domain. So that's the domain, all right? That's what we did there. It's kind of interesting. It's kind of challenging, but once you practice it, it's really not that big a deal. Let's go ahead and do the range, and I'm going to go ahead and clear up this graph while I was doing all that explanation. So let me erase some of this mess that I've made. And I'll fill in the gaps here in a second, wherever I should have left any. Let's put something back here. That was a open circle, I think. Yep, right there. And then we'll do the range. Let's do it in green. No, let's do it in blue. We already have blue out, right? So let's do that. Okay, so the range is a y value. I'm reading it from the bottom to the top. So I start at the bottom. I look at this graph here, and I see that this thing is going downward. It's going downward to what? Forever. Downward to negative infinity. So this part of the actual graph is going down forever, and it's defined for all these values going up. So I'm going to start at negative infinity then. And I'm going to move up the graph right here. And I'm going to have to stop until I get to this y value of what? Of negative 1. I can't go beyond that because that's where the graph is stopped. And there's a gap between negative 1 and 0 because there's no graph right here between negative 1 going up to 0. Now people always ask, what about this part of the graph? Some people even, traced over here and put like negative 7 or something. But negative 7 is already part of the graph for here and all the values below it. So all these values right here are already included right here on this graph. So I actually don't even need this graph. I just look at this one right here. And I go up to negative 1, and I include it because it's a closed circle right here at negative 1, this closed circle right here. And then I have to pick up the graph again at this y value, and this y value right here is actually what? It's actually 0. And then I keep moving up the graph. And how far will I move up? I'll move up the graph all the way to infinity. This will go up the graph to infinity, and that's what this graph is going to do. It's going to go from 0 to infinity, not including 0 because that's an open circle, and you can't include infinity either. So it's a union of this, and that's the range for this graph. Okay, really any other answer you put is not correct. And I kind of took points off for minor things and took a lot of points off for, if it was way off. So that's kind of how I graded a quiz, but this is the quiz. And I appreciate you watching this video. I hope you learn, something from this. And we'll continue to do practice as we go throughout the year. I wish you luck, and thank you for watching.